All right. Hello, everybody, and thanks for joining us in our third Dynamo Office Hours. Really appreciate you guys all coming out. My name is Neil. I'm a technical marketing engineer on the Dynamo team, and next to me I have Kyle. He is an engineering leader and one of the Dynamo co-architects.
Hey, everyone. You may recognize me from a surprise appearance in last Office Hours, and today I'm here to talk more about disaggregation and other techniques that Dynamo uses to make your large-scale deployments of large language models on GPUs more efficient.
Thanks. All right. So we're going to start off. We have a couple of great topics that we're going to talk about today. As always, please, if you have any questions or are curious about things as you come along, definitely let us know either here in the comments or on the Discord. But the topics that we have lined up today, we're going to talk a little bit about the new GPT-OSS model, the open source model from OpenAI that came out on Tuesday. And how you can deploy that with Dynamo and really get some great performance with get the best out of your systems. We're going to talk a little bit about the AI configurator, which is a new tool that can help you sort of determine the best configurations for your model to get the best performance out of them. And we're also going to talk a little bit about how you can get involved with contributing to Dynamo and learning a little bit about the code base and shaping it for your use. So
But first, we probably need to start by giving everyone an introduction to Dynamo to those that haven't seen it.
Yeah, perfect. So we have a couple of slides. If you want to pull those up. So if you haven't used Dynamo before, a great place to learn about it and get an understanding of what it is on the GitHub, github.com/AI-Dynamo. That's where we build everything in the open. We post our issues and pull requests there, and so definitely check it out if you want to learn a little bit more about Dynamo. Another great place to go to learn about Dynamo is on our Discord. We're always checking questions there and trying to build a community of Dynamo users. So definitely a great place if you're curious. Or you could obviously email us directly at developercommunity@nvidia.com. All right, so what is Dynamo? What is Dynamo? Why did we build it? What can you use it for? We go to the next slide. There we go. There's really sort of three core pieces that go into Dynamo, right? Dynamo is a platform for serving, mostly for serving large language models, but can also be used for serving other kinds of AI models. And it's really a combination of three different components. There's scheduling, which is placing workloads on the workers that can most efficiently address them. Yep. There's data transfer, which is moving data between multiple different workers to, again, most efficiently coordinate work. And there is memory management, basically, making sure that things are moving in and out of memory as little as possible and that things are going to the right place for, again, the most efficient execution.
Yeah, and it's the confluence of all three of these things that we believe allows you to unlock true cost, efficiency, and performance for large language models. And all of it's packed into Dynamo. So why don't we unpack that a little bit?
Yeah. So Dynamo really, one of the great things about Dynamo is that it really helps you unlock the performance of large scale clusters and lots of GPUs. And the components of it, you can see some of these on the screen here. There's the smart router, which is taking care of that scheduling portion. Mm-hmm. Of putting workloads on the GPUs that can handle them most efficiently.
Yeah, determining like how loaded the worker is, how much affinity there is of a given worker to a given request, like how quickly it's going to be able to satisfy that request.
Yeah, there's the GPU planner, which helps make sure that GPUs are doing the most efficient thing at any given time based on the workloads that you're seeing. So in particular, being able to dedicate certain GPUs for the prefill part of LLM execution and certain GPUs for the decode part, and being able to sort of dynamically adjust that based on the workloads that you're seeing.
Yeah, it like splits reading and thinking, right? Disaggregation, we split how we read. Oh, we have Jensen Huang visiting.
Oh,
hey,
hey Jensen.
Wait.
Okay. He's checking out the presentation. All right. Do you want to come in? Is he gonna?
Oh yeah.
Oh, all right.
Jensen.
Jensen,
We're
talking about Dynamo. We're live. We're live on the air on YouTube.
You guys are talking about Dynamo?
Yeah,
absolutely.
Disaggregated inference?
Yeah. Every Thursday.
Disaggregating P and D?
Yep, exactly.
What the heck? It's such a good idea.
Yeah,
we certainly think so.
it's
Yeah.
a given.
Well, the problem is the workloads are so different. Sometimes the context is really, really large. And these agentic AIs, they have to go do research. They have to read.
Yeah.
They have to come back, think some more.
Yeah.
Do some planning, do some more reading. And every time you go out and do some search and reading, you gotta think about it. You gotta read, you gotta do the context processing.
Yeah.
Meanwhile, you gotta generate a whole lot of tokens while you're thinking.
Totally.
I don't know what I'm talking about.
More reasoning, more decode.
Wow, look at that. You guys are live?
We are live. Yeah.
Who does live these days?
Me too. We want to meet everyone where they are.
Yeah, we want to be able to answer people's questions when get them,
Hey, you
get them
guys.
engaged.
I work here.
That he does.
This guy's super cool. I like this guy.
Thanks, Jensen.
Thanks for stopping by.
Let's jump back into our components for Dynamo. So for NVIDIA Dynamo, as we were mentioning, we have the smart router, which determines where things go. Jensen gave us a great description about how prefill and decode disaggregation is important. P, or prefill, is useful for basically reading text. It generates, it's understanding of the world from the tokens that you pass in. And decoding is where you generate new tokens. And because these two phases are so different in how they work, it makes sense to split them. And to split them, you have to do a bunch of smart routing. You have to do management of the KV cache, which is basically the previous reading that you've done. You have to pass it on. And you have to communicate it between instances or workers of Dynamo. So we actually provide a low latency communication library called Nixel within the context of Dynamo that's useful for this purpose. And then we also want to manage the KV cache that we have so that we don't have to reread stuff we've already read.
Yeah. It's as Jensen mentioned, when you're doing agentic workloads and a lot of tool calling and sort of back and forth round trips with the LLM, it's really important to make sure that you're saving the KV cache, that things are being placed in the place where they're most efficient, and that you are not having to recalculate stuff that's already been done.
Yeah. Well, why don't we hop into what's new, right?
Yeah, let's do it.
Okay, so let's talk about it. GPT-OSS. For those that aren't aware, OpenAI released their first OSS GPT model since GPT-2 this week. Yeah. It is called GPT-OSS. NVIDIA had partnered with OpenAI to ensure that GPT-OSS runs blazingly fast on GPUs, whether or not they are working in Tensor TLM, VLM, or SGLang, as well as other frameworks for inference and training.
Yeah.
So what's interesting about GPT-OSS? It's a small model, or small-ish compared to DeepSeek.
Sure.
There are two model sizes that they provided, and a 120 billion parameter model that fits on one GPU if you use their FP4 format, quantized format. And they also released a 20B model, which they have said that is usable within the context of a phone or an edge device. Mm-hmm. We at Dynamo are really excited about this. We've been playing with it a lot the last couple of days. It's a great model. And we've been experimenting with Dynamo to see how much we can get out of it. So without further ado, why don't we jump into it?
Yeah, let's talk about it. So one of the things that you can see here is, one of the ways that Dynamo can really accelerate your deployments of GPT-OSS 120B.
Yeah.
So it's a standard deployment that you might normally see is the aggregated deployment, where everything is being run on the same GPU, right? So you got your prefill and your decode being run on the same GPU,
and that's the black line.
Yeah, that's the black line, and that can be a little bit inefficient. You have things competing for the same work. You have different workloads competing for the same resources, and you can't customize your deployment for different parts of the workload. Yeah. And so with Dynamo, you can deploy in a disaggregated manner. And you can see, some of the performance benefits that you get out of that in the graph here on the slide.
Yeah, up and to the right is better, right? That means you get getting lower cost tokens at more tokens per second per user.
Yeah, and so you're keeping also the tokens per second per GPU at the same level in this deployment. So basically, you're keeping costs at the same level while getting better interactivity.
So if we look at it as single point, let's say around 250 tokens per second, we actually see that disaggregation provides a 4 times interactivity benefit at a given throughput per GPU. And what that means is, hey, if you're running aggregated right now and you're running GPT-OSS and you want, some amount of tokens per second per GPU for cost reasons, you can actually get more tokens per second per user, more interactivity just by disaggregating. Users can get tokens 4 times faster because disaggregation allows you to schedule better, and it allows you to use different configurations for the P and the D nodes. And we'll be talking about that a lot more in future office hours, but I don't want to give it all away.
Yeah.
If you're interested in taking a look at how we did this or want to reproduce the graph yourself, we actually have an example within the context of the Dynamo repo of running GPT-OSS on TensorTLM, the 120B model, that achieves this disaggregated performance. And that's amazing, right? You can pick up Dynamo right now and get 4 times the interactivity at the same cost by just switching to disaggregation in Dynamo.
Yeah, and so definitely we encourage you guys to check this out, take a look. It's a really great way to deploy Dynamo, or to deploy GPT-OSS and get really good performance out of it. If you guys have any feedback and checking out the walkthrough, definitely let us know either in the Discord or you can open up an issue on GitHub. We'd love to hear from y'all.
Yeah, well, let's go back. What else are we really excited about for Dynamo these couple of days?
Yeah, great question. So another thing that we've heard a lot of feedback about is that as we start introducing some of these concepts of disaggregation and being able to have different kinds of configuration for your prefill and your decode, it becomes really difficult to kind of reason about and predict what exactly is the best way to deploy my model, the best configuration that I can use in order to get the best performance.
Yeah, you go from having like 10 options. Let's assume you had 10 options for an aggregated scenario. You're at least doubling the number of potential levers you can pull to change the performance of a disaggregated setting. So it really quickly explodes into a huge amount of options. And we want people to use disaggregation because we think it's amazing. So we built a new tool.
Yeah, and that's the AI configurator tool. It's going to be coming soon. You'll be able to to download it and take a look at the predicted performance for various different configurations. You can see the CLI here on the screen. There's also going to be a web UI that you can click around with to explore a little bit more easily. Yeah, what the graph that you see here is a good representation of the kind of performance curves that we like to look at, and we think is the best way of sort of understanding the various configurations and the best and the kinds of performance that you can get.
Yeah, farther to the right on this graph, we have the tokens per second per user, which is how interactive, how quickly the user get your tokens out of the application. And far to the left, or sorry, on the y-axis, we have the tokens per second per GPU, which is basically how efficient or cost efficient is your generation. So if you're, for example, working in an application that needs, a lot of tokens per second per GPU, but at like a fixed latency, what you can do with AI configurator is you can actually tell it to basically draw a line at a point and choose the best configuration at that point and give it to you. And you can run that within the context of Dynamo out of the box and check reality against the prediction.
Yeah.
And we hope that this enables people to more easily configure Dynamo and get great disaggregated performance out of the box. AI configurator will be launching shortly hopefully with our next release. And we have a number of pre-configured models that you can pick up and use in them, among them GPT-OSS and a couple of others. We're really excited to see what people do with AI configurator and with, of course, GPT-OSS in the next couple of weeks. I think that, we've really covered a lot of what has really been happening the last 2 weeks for Dynamo.
Mm-hmm.
Why don't we take a couple of questions from the audience?
Yeah, let's do it. And I think we can start off with a question that we got earlier today in the Discord channel. Hello, I want to contribute to the Dynamo project. I'd love to know if there's any way to get started if I don't have access to a GPU. Would Triton be a good choice? Is it possible to contribute if I don't have a distributed system to test? Great question.
Yes, you can use Dynamo without a GPU. You can use Dynamo without a distributed system, and you can contribute without access to many GPUs or a distributed system. So first of all, how to contribute. If you are new to contributing to Dynamo, we love you guys. We want you to engage. We have tagged a number of issues within our GitHub repo with the label Good First Issue. So if you select this label, Good First Issue, you should see issues that we believe are a good entry point to Dynamo, its code base, and to the languages that we use, like Rust and Python. So if you would like to contribute, you can, open up, this issues page, type in label Good First Issue, and then identify something that you want to work on. In our case, we have some stuff for our visual UI for booting up Dynamo. We have some request migration and fault tolerance topics. Please feel free to come and pick one of those up. If you'd like to talk with us about an issue before you pick it up, or want to, sort of identify if there's something that you want to work on that you'd like to propose in Dynamo, please feel free to propose that via issue or feature request, or come talk to us in Discord, also seen at discord.gg/NVIDIA Dynamo. Please join us there. I think we have another couple of questions in the chat.
Yeah, let's do it.
If you'd like to ask a question, by the way, please feel free to use LinkedIn, our X stream, our YouTube stream, or our Discord stream. They're all running right now, and we can see them all. So please feel free to ask your questions.
Okay, I think we got a question here. So GPT-OSS is a chain of thought model. So I haven't tried it as the brain for agents yet. I have a commercial voice-based agent in deployment. Is there a model similar in power to 4.0 you can run on NVIDIA NIMs or Dynamo that can get around 400 milliseconds turnaround on the first token outputs after accounting for context caching? All right, that's a
model similar to 4.0. I don't believe that there are many open source tech or audio to audio models out there.
Yeah.
However, there are a set of models from NVIDIA that would allow you to compose a system for basically doing something similar to 4.0 that allows you to take in audio, convert it into text, use that text through an LLM, and then output the audio given a voice. Notably, there are a bunch of projects within NVIDIA ASR, which would be like speech recognition and text to speech, that like the Parakeet model that NVIDIA has released, and you can see on Hugging Face, that would be capable of doing this task for you. Yeah,
and one of the really nice things about Dynamo is because it's kind of modular and you're able to deploy sort of things as like separate components, it actually becomes a lot easier than in some previous systems to be able to deploy multiple different models and pipe them all together, sort of stream requests across all of them, and process it in a really efficient way, even if you don't have everything running on the same GPU. So it's a great use case for Dynamo. Oh, okay, so it doesn't need a voice model.
Yeah. Let us get back to you. Please feel free to reach out on Discord, and we can do our best to find something that will help you in the context of Dynamo.
Yeah, definitely.
We had another Discord question. Does Dynamo or disaggregated serving work with GPU sharing techniques like MIG, i.e., can I run prefill on a slice of GPU and decode on another slice? MIG is a great virtualization technology for those that aren't aware. However, the purpose of disaggregation is really to split out those two phases so they don't contend for resources. And MIG would result in explicit contention for resources. So it's likely that using MIG and Dynamo together wouldn't result in better performance, simply because it wouldn't allow, relative to the aggregated scenario, it wouldn't allow for the same type of resource sharing between the two phases.
Right.
And you just end up with worse performance because you're not getting the resources.
You're getting the overhead of sort of data transfer without the benefits of dedicated hardware for different pieces. So yeah. It is an interesting question though. I'm not sure that we've done like any explicit benchmarking with MIG. It might be a great thing to try out.
Yeah. We had a couple of questions. We had a question earlier today from actually a contributor that was asked, which was, how do we expect that disaggregated serving is going to change? Are there any new things we're looking at in disaggregated serving? And the answer is yes. There are disaggregated serving is changing every day. It's actually a really popular topic of research. So there are some really cool new techniques that are being used in disaggregation to even more identify places where we can basically tweak the equation a little bit so that our utilization of resources is better. We drive higher batch sizes. One that is quite interesting, and we were looking forward to trying, was released in a paper coming out of Step Fun. It was a Step 3 paper. They reintroduced in a pre-existing form of disaggregation called attention feed-forward disaggregation, in which you actually go even further and take the decode phase and split it into attention and the feed-forward part of the model. So attention being the part that looks across the entire sequence, and it determines the relationship between tokens and uses that relationship to basically calculate how much each token matters to each other token, and then combines the values. And then also the feed-forward part, which is completely stateless, right? So you can just, basically do your attention, pass it to the feed-forward, and then repeat that on the next layer.
Yeah, and the principle there is fundamentally pretty similar to the reasons that we're doing prefill and decode disaggregation, where the actual computational patterns of these two phases are pretty different from each other, right? And so it's good to be able to have hardware dedicated to certain portions in order to sort of most efficiently take advantage of those.
Okay, well, I think we're just about out of time, and we've covered everything for today. If you're interested in contributing to Dynamo, asking more questions, or engaging with us, please feel free to meet us on GitHub or Discord. We're very excited to chat with you and share the newest things that we're seeing in disaggregation and in large-scale distributed model serving. And really importantly, we want to hear about what you want to learn about. Are there specific things in Dynamo or techniques that we can help you, basically understand, or are there techniques that even we might not know about? Please let us know. Check in on Discord. Check in also 2 weeks from now for the next Dynamo Office Hours, and feel free to ask questions ahead of time. Send them to us via Discord. We also have, I believe, plans to do more forms of polling. We'll push those out later. Yeah, thank you so much, everyone, and we hope you have a wonderful week. Keep enjoying these OSS models. Enjoy GPT-5. Enjoy Dynamo, and we'll see you soon.